If you've ever worked with data, you totally know this feeling. You've got a problem to solve, a question you need to answer, but building a great machine learning model, it feels like searching for a needle in a haystack. But what if you could automate that entire search and have the perfect needle delivered right to you? Let's dive into how that's possible.
Every single data practitioner, I don't care if you're a beginner or a seasoned expert, gets stuck in this maze. You have your data set, you know you need to build a predictive model, but where do you even begin? The number of choices can be, well, just plain overwhelming.
And this right here is the million-dollar question, isn't it? Which approach is going to be the winner? Should you use a simple decision tree, or maybe combine a bunch of models into a powerful ensemble? Or go all out and build a complex deep neural network? It's incredibly hard to know in advance which algorithm will perform best for your specific problem until you basically tried them all.
This slide just nails the frustration. The traditional way of doing this is a manual, iterative process of trial and error. It demands deep expertise, a ton of intuition, and you're sifting through a nearly infinite number of parameter combinations. It's just a slow, resource-intensive grind.
But what if there was a better way? What if you could just automate this entire painful process? Well, that is exactly what OptiML is designed to do.
So what does it all come down to? It's this. OptiML automates the entire process. It handles both picking the right model and finding the perfect settings for it, what we call parameterization. And it works for both classification problems, where you're predicting a category like yes or no, and regression problems, where you're predicting a number. It simply takes all that guesswork out of the equation.
I love this quote. It really gets to the heart of it. By automatically finding the best model, OptiML lets everyone, not just the experts, build top-tier models. It's like having a seasoned data scientist on your team, working tirelessly to test every option and present you with only the best. This frees you up to focus on the results, not the process.
And this icon says it all, doesn't it? It visualizes taking that tangled, complex path of model selection and transforming it into a single, streamlined, and efficient journey, straight to the best possible answer.
So how does it pull this off? It's not just brute force. No, there's a very clever engine working behind the scenes.
The secret sauce here is a technique called Bayesian parameter optimization. Now, in simple terms, it's a smart search. With each model it builds and tests, it actually learns. It uses the results from its previous attempts to make more intelligent guesses about which parameters to try next.
This whole thing boils down to a pretty simple two-phase process. First, it performs that smart search for the best models in their settings. Then, for the top candidates it finds, it performs a really rigorous check called cross-validation, basically testing the model on different slices of the data to make absolutely sure the results are stable and reliable, and not just some lucky fluke.
Okay, that's all the theory. But what does this actually look like for you, the user? You might be surprised by just how simple it is. This is the magic right here. From your dataset view, it is literally one click. You select OptiML, and the entire automated search and validation process kicks off immediately. No complex setup required to get started. It's that easy. And what's so brilliant about this is its appeal to everyone. For beginners, that one-click start is all you need to get world-class models. But for the experts out there who want to control every little detail, a deep set of configuration options is waiting just below the surface. And this illustrates that power perfectly. Experts can specify exactly which model types to test and choose the precise performance metric to optimize for, whether that's simple accuracy or the more nuanced F measure, which balances different types of errors, or something else entirely. It's simple on the outside, but incredibly powerful on the inside.
All right, let's move to the payoff. Let's see how this all builds to the final result. What do you get at the end of this automated search?
While it's running, you get this fantastic progress view. You can actually see in real time as OptiML evaluates hundreds of model candidates, which gives you a real sense of the sheer amount of work being done automatically on your behalf.
And then the grand finale. You get this clean, beautiful dashboard. This is your command center. No more messy spreadsheets or notebooks. Just a clear, ranked list of the top-performing models ready for you to explore.
In this results view, everything is right at your fingertips. The models are ranked by the performance metric you care about. You can compare completely different algorithms side by side. You can click on any model to deep dive into its specifics and even export the entire leaderboard to a CSV for your reports.
So what does all of this mean for you? This isn't just another feature, it's a fundamental change in how you can build models. It's seriously like gaining a new machine learning superpower.
So let's just summarize. OptiML automates the most tedious part of machine learning. It puts elite modeling techniques into the hands of non-experts. It uses a smart search to efficiently find the best models, evaluates everything from deepnets to ensembles, and presents it all in an interactive dashboard so you can confidently pick the winner.
So I'll leave you with this question to think about. When finding the optimal model is no longer a bottleneck that takes weeks of manual effort, but something you can achieve in just minutes, what new questions will you ask? What new problems will you solve? The possibilities are truly wide open.